Hi, my name is Molly Goldberg, and welcome to the show, The Science Behind the French Fruit Tart. Today I'm going to show you how to make a tart and how it relates to chemistry. First, I'm going to be making pâte à choux dough. It includes butter, salt, sugar, flour, and 1 egg yolk. And then the tools I'm going to be using are a knife, a spatula, a pie pan, and plastic wrap. I first cream the butter, sugar, and salt. This is an example of solute, solvent, and solution. It happens when the water that is in the butter dissolves the salt and sugar and brings it together to create one mixture of a dough. This happens when I mix all the ingredients together in the same mixture to create a new product. It happens because the water is acting as the solvent while the salt and sugar are the solutes. The solvent dissolves the solute when I mix them together. The more I mix them, the faster the dissolving process will be. Next, I add the flour and mix until it is incorporated. Then the egg yolk goes in and gets mixed. Once the dough forms, I knead it into a ball and wrap it in plastic wrap, and then it goes in the fridge for about 30 minutes. After the dough has cooled, I spread it evenly in the greased pan. It then gets wrapped in plastic wrap and placed in the freezer for around 30 minutes. I preheat the oven to 350 degrees, then I place it in the oven for 25 minutes until golden brown. The baking is an example of activation energy, which is the minimum quantity of energy which the reactant species must possess in order to undergo a specified reaction. Activation energy is when I'm baking the pâte à choux dough. It happens because it's taking the minimum amount of energy it needs to cook the dough until it's just perfect. The dough starts from a soft dough, and then baking it turns it into a harder dough. Next, I'm going to make the custard. It includes butter, eggs. 2 of them are going to be just yolks and one's going to be full. Sugar, milk, vanilla, and cornstarch. Also, the materials I'm going to be using are a pot, plastic wrap, a spatula, and a whisk. First, I bring the milk to a boil. Boiling the milk with specific heat, which is the heat required to raise the temperature of the unit mass of a given substance. It happens when I boil the milk in a custard. When the milk begins to heat up, all the water evaporates from it, leaving just the milk. The milk reaches a specific heat of 0.945, which is lower than water's. Because of the specific heat being lower, it takes less heat and time to raise the temperature of the milk. In a bowl, I mix together the sugar, egg yolks, and cornstarch. Next, I add about 1/4 of the hot milk to the mixture. Adding the milk to the mixture is conservation of mass. The cornstarch and milk are the reactants and create glucose by combining together. The balanced equation is C6H10O5N plus H2O, which results in NC6H12OC. This is a conservation of mass because mass is neither created nor destroyed in any chemical reaction. Therefore, a balancing of equations requires the same number of atoms on both sides of a chemical reaction for it to happen properly. Next, I mix everything together in a pot until it is thickened. Then I add the buttered vanilla and mix once more. This is a phase change. A phase change is when matter changes from one state, solid, liquid, or gas, to another. It happens when I return the pot of milk and eggs to the heat. I need to whisk constantly to help it to change to a thickened form. This is a phase change because it is going from a thin liquid to a thicker liquid, almost on the verge of becoming a solid. I then pour the cream in the bowl and cover with plastic wrap and let it chill for a few hours. Now I can assemble the tart. I add all the pastry cream to the tart shell and smooth it out. I then add fruit for the topping. Thanks for watching the science behind the fruit tart.